Welcome back to AP Calc, everybody. So we're going over Unit 4 review, contextual applications of differentiation. So follow the directions to answer each of the following problems. Only use your calculator when a problem displays a calculator icon. So topic 4.1 and 4.3, interpreting the meaning of derivative in context, rates of change in applications, context other than motion. All right. Eager rock fans enter a line to buy tickets to see the renowned band Sir Isaac and the Newtones at a rate modeled by the function given by E of t equals 512.7 times e raised to the negative 0.173t, where E of t is measured in people per minute and t is measured in minutes for the interval between 0 and 30. Find E prime of 22 and using correct units, interpret its meaning in the context of the problem. So again, remember one of the things that we want to do the most is interpret the meaning, right, of what we're looking at. So let's start off by pretty much writing down the important information, and let's highlight that first. So we see that we have a function again. This is a calculator problem. All right. This is a calculator problem. And E of t is measured in people per minute. So those are the units. And the minutes, right? T is minutes. And again, it's for the first 30 minutes. And then we need to find E prime of 22. All right. So again, this is something that you guys can do in the calculator easily. Please make sure you do. You don't need to find necessarily what E prime of t is. You can just figure out what's E prime of 22. And then again, you can just go to Desmos. All right. Desmos. E. There. And then we have our function. I typed in x instead of t because Desmos likes x a lot better. And then I gave the function the prime of e. I gave it the name f of x. So all I need to do now is find f of 22. And that will give me the answer right there, which is negative 1.972. So 1.972. All right. Back to the problem. So we can say E of 22 is equal to negative 1.972. Right? Remember, you can just truncate, meaning you can just cut it off at the number right there. And the units for this is people per minute squared. All right. So it's minute per minute. Remember, it's already minutes here, so we're gonna add one more unit to the minute to the time section. All right. So here again, we can say in this case, the explanation, the end, interpreting the meaning in the context of the problem, would be that the rates at which people are entering. So people are entering the line to buy tickets is decreasing, right? Because it's negative, is decreasing by 1.972 people per minute squared, right? Per minutes, pretty much. All right. So if you guys notice one thing again, some of you guys keep making this number negative. If I'm already saying the word decreasing, that means that the value is negative. So therefore it is going down. All right. Looking at problem 4.2, line motion, connecting position, velocity, and acceleration. So here we're looking at the graph below shows a velocity v of t of a particle moving along the x-axis and can be defined by a continuous linear piecewise defined function over the interval between 0 and 9. It says note that v prime of t equals 0 on pretty much between x for x between 3 and 4. So we're looking at the graph. It says over which time interval does the particle move to the left? Justify your answer. So again, here we're looking at the graph of v of t, right? So if the particle is moving to the left, right, this is v of t. I'll make sure I'll write it a couple times right there. Since the particle is moving to the left when v of t is negative, right? When it's less than 0, that's when it's moving to the left. It's moving to the right when it's positive, right? Right, right. So here in this case, whenever v of t is negative, meaning it's below the x-axis, that's when it's moving to the left. So over which time intervals does the particle move to the left? Justify your answer. So right here, we're looking to see it's about between 0 to positive 2. Let's just round it off, right? So between positive 0 to positive 2. And also, it seems to me between 6 to 9, right? Between 6 to 9. All right. So justification for our answer would be pretty much we can say the particle moves to the left on the intervals on t is between 0 and 2. So t less than 2 and 6 less than t less than 9 because v of t, right? Because v of t v of t is less than 0, right? Meaning it's negative. So that's pretty much your explanation right there. It says over which time intervals is the particle speeding up? So when a particle is speeding up, right? When a particle is speeding up, both that means that both a of t is less than 0 and also v of t is less than 0, meaning they're going heading in the right in the same direction, or both of them are positive as well, right? So that's pretty much where we want to look at. So now remember that a prime, I'm sorry, a of t would be equal to v prime of t. So to figure that out, so that's pretty much just the slope here, right? So when is the slope increasing? So we know between 0 and positive 3, right? A of t is greater than 0, meaning it's positive because it's increasing. Here, a of t is equal to 0, right? Because it's not changing, it's just flat. And then from 4 to 8, a of t is negative. And then from 8 to 9, a of t is positive again. All right, bigger than 0. So here again, one of the things we're looking for is when is both of these are positive. So you can see that between 2 and 3, it should be speeding up because a of t is increasing and also v of t right here is greater than 0. So we can say for sure that the particle is speeding up, right? So again, the particle is speeding up So the particle is speeding up on the interval. On the first one we found was between 2 and 3. So on the interval, 2 less than t less than 3, because v of t and a of t are positive, right? And then the second part, so now let's keep looking to see where the other one would be. So here, both are negative, right? V of t starts being negative between 6 and positive 8. So that means that the particle should be speeding up also between 6 and positive 8. So again, the second part of this statement, we can say that the particle is also speeding up. The particle is also speeding up uh, on the interval. Oops. In this case, between 6 and 8, right? T is between 6 and 8. And then here we just want to say because both A of t and V of t are negative. And then it says over which time intervals is the particle speed decreasing. So here now we're looking at when are both like having opposite signs, right? So for sure that would be pretty much anywhere else where we didn't see where it was speeding up. So between 0 and 2, we can say that the particle is slowing down. So the particle is slowing down between, well, not between, I can just on the interval. On the interval, 0 less than 2. I'm sorry, less than t, less than 2, because both a of t, or not, but because a of t is positive, right? And v of t is negative, less than 0. And then the particle is also slowing down on the interval between 4 and 6. And on the interval between, uh, not between again, sorry, but on the interval 0 or 6 less than t less than 8. Oh, no, sorry. Actually, wrong one. So the interval is right here, is between 4 and 6. So between 4 and 6, right, 1 is positive, b of t is positive, and then b of t is negative. Oh, no, backwards. A of t is less than 0, and v of t is greater than 0. Okay. So, and then finally, one more, the last one where it's slowing down would be pretty much between 0 and 8. And that one would be, I could just add it in here. I can just put and between 8 and 2. I'm sorry, 8 and 9, right? 0 less than 8 less than t less than 9. All right. So I just forgot to add that interval in there as well. And then that's pretty much it for question 2.